Hello, welcome everyone. This is another video where I'm going to demonstrate how to use power rule when we're using root functions or square root or cube root, whatever the functions are. So let's take a look at this right here. Let me just close this real quick. All right, so here's our power rule, which is if you want to take the derivative of a function of n polynomial function, it's equal to n times x to the n minus 1. So n becomes the coefficient, and then you subtract 1 from the exponent. So it's n times x to the n minus 1. And the other property that we need to know is that when we have a constant multiplying with our function, we can take the constant out when we take the derivative of that function. So it would be just constant times the derivative of function. That's the way to do that. So I'm going to write down this right here. If we're taking the derivative of x to the n, it becomes n times x to the n minus 1. And if we are taking a derivative of some constant times a function, it becomes the constant comes out of the derivative, and then we have d over dx of this function f of x. Okay, so these are the two properties we are going to use in this video. So we have a square root of x. So I'm going to simplify this first. So square root means that the exponent is 1/2. So I'm going to write it as x raised to the 1/2 power. And now I'm going to go ahead and take the derivative of this, d over dx of x to the 1/2. And now we can apply the power rule. So the exponent becomes a coefficient, and then we have x to the 1/2 minus 1. So this is 1 over 2, and then when we simplify 1/2 minus 1, it becomes negative 1/2. Now we're going to use another property of exponent. Whenever we have exponents that have a negative, whenever we have a function or something, expression that has a negative exponent, we can change its location. We can bring it in denominator and change the sign of the exponent. So this would become 1 over 2 x to the 1/2. You can write it 1 over 2 times square root of x. So these are all correct answers for this particular problem. So just you have to know the the little bit of manipulation you have to do in the exponent laws towards the end to depending on which form of the answer they wanted from you. So here we have this example, we have square root of 3x. So first I'm going to separate the terms inside the they're multiplying. So multiplying and division, you can separate them if they're under square root. So not in the subtraction and addition. So we have square root of 3 times square root of x. Okay, so x, not 3. Okay, so I separated this into these two terms right here. Okay, this one quantity into two separate terms, and they are correct. You can put them under one square root if they're multiplying like this, or you can write them individually as I did. So it would help us to calculate the derivative easier. So I'm going to take the derivative of this, d over dx of square root of 3 times square root of x. So we take square root of 3 out, d over dx. And I'm going to change this square root of x to the 1/2, which is the same as square root of x, because we're going to subtract the degree. We're going to subtract 1 from it, from the exponent. So it would, we need it in the number form. So we have d over dx, and then we have x to the 1/2 minus 1. And when we simplify this further, it becomes square root of 3 times x to the negative 1/2. And if we want to simplify it further, it becomes square root of 3 over x to the 1/2. It's a negative exponent. We can bring it in denominator to change the sign of the exponent. So you can leave it like that, or you can also put a square root instead of 1/2 there. So it would be square root of 3 over square root of x. And you can also even further put them all under one square root, so it would be square root of 3 over x. So all these are correct answers for this particular problem. Let's go ahead and work a couple more examples out. So here we have a cube root of x squared. So the first thing we want to do is just a little simplify it. So we have x to the second power raised to the third. This is what cube root means. It's the raised to the 1/3. So here we're going to use a property. If we have x raised to the mth power and that's raised to the nth power, so we can write it as x to the m times n. So here we're going to do x to the 2 times 1/3, which is basically x to the 2/3. So this is the simplification is done. Now we're going to take the derivative of that, d over dx of x squared, x to the 2/3, not x squared. Okay. Now we simplify this further. We have 2/3 comes to the front, the exponent, times x to the 2/3 minus 1. And then we go ahead and simplify it further. And we simplify this portion right here. 2/3 minus 1 is going to be negative 1/3. And then we can use the laws of exponents and bring this into denominator and make it a positive. So x to the positive 1/3. All I did is I brought this from numerator into denominator. And now I can just write it as 2 over 3. And x to the 1/3, you can write it as the cube root of x. So this would be your final answer. And now let's go ahead and do this next problem. So I added a coefficient, so a constant to our function right here. So in this case, we have to apply the second rule as well. We're going to take the constant out of the function term and then differentiate or take the derivative of the remaining part. So here, first I'm going to go ahead and simplify it. I'm going to write it as, I'm going to break it into two parts. So it's going to be cube root of 4 times cube root of x squared. Okay, so I broke this, since they're multiplying 4x squared, you can write them as independent terms as a multiplication. So cube root of 4 times cube root of x squared. So now here we can go ahead and take the derivative of this. We have cube root of 4 times cube root of x squared. And now we take this cube root of 4 times d over dx, and we have x squared and cube root of that left inside. Now I have to simplify this a little further. This is a cube root. This is a cube root of 4. Okay, so let me just write it a little better. Though it's not a coefficient, it's a cube root of 4. And then inside I'm gonna actually further simplify it. So this becomes x squared to the 1/3. And then we use this property right here of exponents. When we have x raised to the m power and raised to the n power, we just multiply the exponents. So we have cube root of 4 times derivative of x to the 2/3. When we multiply these two exponents, it becomes 2/3, and now we take the derivative. So we have cube root of 4 times this 2/3 becomes the coefficient, and then x raised to the 2/3 minus 1. So we have cube root of 4 times 2/3 x to the negative 1/3. When we simplify this right here, this 2/3 minus 1, this is what we get. And we can leave it like that, or you can simplify it further. Let me just add a new slide so we can go ahead and simplify it further. I don't have enough space here, so we have this cube root of 4 times 2/3 times x to the negative 1/3. And I'm going to simplify it further, bringing this in the denominator and to make the exponent positive. It's x to the negative a equals 1 over x to the a. This is the property of the exponent we are going to use here. So we have cube root of 4 times 2 over 3 times 1 over x to the 1/3 power. Okay, and then we can just multiply and make just one whole expression. So we have cube root of 4 times 2 in the denominator is just 3 times x to the 1/3. So 2, you can bring it to the front, so 2, and this is cube root of 4 divided by 3, and x to the 3rd, you can also write it as cube root of x. So this would be your final form of this answer. I mean, all these forms are correct. You can leave it. It all depends what is expected from you. This is correct as well. This is correct as well. And this is correct as well. And this is correct as well. So all these are correct answers to that particular problem.